So we're gonna find the greatest common factor using prime factorization. So let's make up some random numbers. Let's make them easy though. Let's add 20, 50, and 120. Alright. So my goal is to find the greatest common factor using prime factorization. So first thing, you could do it multiple ways. You could use a factor tree in order to factor them down to their prime factors. I'm going to do that. So I got 20, okay, which is 10 times 2, right? Then I can do 5 times 2, and this is prime right here. And these are my prime factors. So I'm going to do 5 times 2 squared, since I have two 2's, right? Alright, now let's do 50. So 50, let's do 25 times 2. This is prime here. 25, do 5 times 5 to get the 25. These are my prime factors for 50. So I can write that as 5 squared times 2, right? Now I got 120, the big boy, right? So 120, I can do, let's say 40 and 3, right? 3 is prime, 40 not so much. Let's do 20 times 2. 2 is prime, 20 not so much. And then 10 times 2. And then we got 5 times 2, right? And these are my prime factors right here for 120. Alright? I could write this as 5 times 2 cubed times 3. Alright, in order to find the actual greatest common factor of all these three numbers, I'm going to take what they have in common, what each of these three numbers have in common, and multiply those together. So for example, I have a 5-year, a 5-year, and a 5-year. So each of these have at least one 5 in common, right? So I'm going to write that. And then I can write 2 5s because only one of them has 2 5s, 50. The rest of them have 1 5, so they have 1 5 in common. Next thing they have in common is 2, right? And this one has 1 2, so they all have at least 1 2 in common. And this is the only one with 3, so that's not in common. So that's it. I just multiply the prime factors that they have in common. So 5 times 2 gives me 10. So the greatest common factor of these three numbers is going to be 10. Hope this was helpful. Thanks for watching.